Okay, we're going to start our discussion of Chapter 7, which is on radical functions and rational exponents. We're going to start with roots and radical expressions. Let's look at our first example. We're going to try to find the root of each real number. So we want to find the cube root of negative 1,000. So we want some number multiplied by itself 3 times to give us negative 1,000. So that number is negative 10 cubed. So negative 10 times negative 10 times negative 10 is negative 1,000. So negative 10 to the third is what we're looking for. And this root and this cube will cancel each other out essentially, and you're left with what's left in the parentheses, which in this case is negative 10. And if we look at this definition, it says the definition of the nth root. So when n is 3 or when it's an odd number, there's only one real cube root. Let's look at example B. The square root of negative 81. So let's think about this. Is there any real number that we could square and get negative 81? There is no real number whose square is negative 81. So in this case, there's no real number. We can't find the real number root of this. Let's look at simplifying radical expressions. So simplifying just means taking whatever we can out of the radical and putting it on the outside. So we can think of 9 as 3 squared. And we want squared because this index, that's what the number right here is, there's always this imaginary 2 if there's no other number there. So the index in this case is 2. So 3 squared is 9. And 10 or x to the 10th is really x to the 5th squared, because how many times will 2 go into 10? It will go in 5 times. So we can simplify this to 3x to the 5th squared. And remember, anything that's in a parentheses, we're going to bring outside. So this becomes 3x to the 5th. And in this case, we put these absolute value symbols on either side of the x to the 5th because we only want the positive value of this because it's a square root. So absolute value symbols ensure that the root is positive when x is negative. Let's take a look at example B. This time we want the cube root of a cubed times b cubed. Well, this is really a times b cubed. And once again, this cube and this cube root in this particular example will cancel each other out, and we're just going to be left with a b. And we don't need an absolute value symbol here because this index is an odd number. So the absolute value symbols must not be used here. If a or b is negative, then the radicand is this thing that's underneath the radical, is negative. And the root must also be negative. That's it for 7.1 in terms of the new content. So I want you to try these quick checks on your own. If you want to, you can pause the screen here. You'll have a chance to ask questions in class. Have a great day.